Okay, welcome back. Before we actually move on and keep going and doing some soldering with all the other components like these resistors, 1K, 2, 10Ks, and 4 mega ohms, we're gonna talk about a few things. And you like actually my hands? I clipped my nails and put some lotion on it, man, because my last couple stints of this video, look, my hands look horrible. Like I was completely unkept, and I'm sorry, I'm off track. Okay, let's actually go back to this, okay? Let's actually concentrate on this Arduino, all right? And we're going to concentrate on 4 of the pins here. Let's talk about this all here, which you should have on your downloadable printout. D13 is going to be an output pin, which with the code that we already uploaded onto the chip of the Arduino, it should be supplying a signal to the relay module right here, okay? Now, that being said, the relay module is going to be getting a 5-volt power supply to the external 5-volt regulator, okay? It's not going to be going internally here. Now, when it's hooked up to your computer, it's not going to work because it's getting external power from the external source, okay? The reason why we're using that or doing it that way is so that every 5 volts possible can be used to power the code or internal workings of this whole circular diagram, this whole closed circuit. Now let's talk about the other inputs, which is going to be the ref input. We're going to start with that. It's going to go to 1 mega ohm and then to a 10K resistor. Okay, after that, it's going to connect into the A analog 0. Then it's going to continue daisy chaining from this solder joint and to a 1 mega ohm, and it's going to solder to a 10K resistor, to another 1 mega ohm, to one more mega ohm, coming down here to a 50 volt capacitor. On the anode or positive side, we're gonna break out of that chain and add our copper plate source or wire. In this case, we're using a Cat5 cable hooked up to whatever, something conductive. Then we're gonna jump back into the capacitor, and then we're gonna go ahead on the cathode or ground side. We're going to break out of that and use a 1K resistor, and then going down to the copper plate or anything connective. Then from the capacitor, from the cathode leg, we're going to continue on and hook it right up into the ground of the Arduino, closing that circuit. Okay, that's what it's going to look like, and that's what's going to help with the human circuit. All right, so let's go ahead and continue and get on with this. All right, enough of my jibba jabba. Okay, let's do it. All right, so if we're ever going to survive, we need to get a little bit crazy, okay? We're going to survive unless we get a little crazy. Okay. Guys remember Seal? Okay, well, let's keep going on. So, as the diagram showed, we're going to hook this up using just the legs of the components itself, all right? Oh, yeah, we're getting crazy here. So what we're going to do is we're going to go ahead and slide this 1 mega ohm right into the A ref, okay? Right into the A ref. See that? It's going into the A ref. Yeah. How many times do I have to say A ref? This is the ref. And we're going to just twist it once. Wow. Check that out. We just twisted it once. Okay, and we're going to take our needle nose pliers and we're going to go ahead and grab this, and we're going to actually tighten that wire knot. Grab the 10K resistor, and we're going to go about the midway point and twist it like that, okay? Twist it twice on that side and twist it twice on this side, okay? So it just kind of like locks up like this. Now, we're going to get really crazy here, and we're going to loop it all the way back over and bend it down through the A0, okay? Analog 0. This is not recommended to do it this way, but I'm going to do it this way because I want to demonstrate that we can actually do it this way. Hey folks, just to clarify, because I know I'm going a little bit fast, but right here from the 10K resistor going into the analog 0 or the A0 pin, all I did was just go inside the pin and then just loop around and back out and making this little snake tail at the end here. You're probably cringing at me right now, but that's just what I have to live with, okay? Now that we've done that, we're going to take a moment and solder this to what we have so far, okay? Taking our trusty piece of painter's tape, slam this down here, so it doesn't move so much, and we're going to prop it up like that, okay? You're probably doing it the right way, like on a circuit board or perf board or whatever you're going to use. So what I meant by perf board is what you see on the screen here. This is perf board. You might be using this and it's going to look way better than my plywood or something that looks like this. You might even be using a breadboard, but again, this is my my hunk of plywood that I'm actually using. But I don't have any of that, so this is what I'm going to do. I am going to grab some solder, and I'm going to now grab my mask and my protective gear because I don't want to breathe in this stuff. We're just going to do this. So this is what I did, all right? They're nice solder joints in terms of, like, when I say nice, it's solid. I don't solder very well. As you can tell, it looks very cringy, but just to bring home the point, the joints are very solid onto the actual Arduino pins, and that's the most important part, so it's actually getting a good connection. Yeah, that looks gross, but yeah, let's move on. So anyway, I wanted to keep this little tail out on purpose, okay? Because I'm going to take another 1 mega ohm resistor, okay? We're going to go ahead and twist this on here once, twice, 3 times a lady. Remember that song, Commodores? All right, let's just move on from that. You just want to get a good twist. I'm going off camera. A good twisty twist. Not just a twist, but a twisty twist, okay? There's a difference. There's really not, but just go with me. So let's go ahead and put this down to Chinatown, okay? We're going to go ahead and lay that down, and we're going to focus the camera. Put my mask and protective stuff on, which I'll probably fast forward. Oh, man, I really need to buy a fan. I really need to buy a fan, okay? This takes too long. Rocky, no, get away from my glasses. Drop my glasses on the ground. I'm a cat. So yeah, this is Rocky, my cat. Here we go. Check this out. You guys are probably cringing, but whatever. We're snipping this off and making it a little bit more clean. Still looks like junk, but at least it looks like clean junk, right? When I'm clipping this stuff off. I'm not even sure what that means, but just go with me, alright? Now, we're going to take the last of the 10Ks, twisting it this side, that side, so we got this crazy looking joint here. Take our painter's tape and make it all funky monkey so it props up like this. Oh, look at that. Look how good that works. That doesn't work good at all, but that's just the way I roll, you know? All the actual electronics majors out there are really cringing right now at this horrible circus show that I'm doing here, but I promise you it's going to work. It's not going to look pretty. In fact, it's going to look pretty clowny, but just go with me, all right? Just go with me. Now, we got a mega ohm 10K, and we got to do the last 2 of our mega ohms, okay? Our mega deaths. Alrighty, before we move on, and I know I'm going really quickly in these tutorials, I'm actually using the fast forward button a lot. I'm going to go ahead and clarify on screen what's happening here. If you're soldering along with me, this is what we both should have. The ref pin has a 1 mega ohm resistor trailing off to a 10K resistor going into the A0 or analog 0 pin, coming out to the 1 mega ohm resistor, connecting to the 10K resistor, connecting to the last 2 1 mega ohm resistors, so 2 mega ohm resistors. We're going to go ahead and hook up our trusty capacitor, alright? Alright, and just to reiterate, this is a 50 volt 1 microfarad capacitor. So let's keep doing this, alright? So we're going to take our positive side, which is the longer leg, this one, and we're going to bend it out, have him do a little bit of stretches, calisthenics. We're actually going to be using this wire, okay? Oh, if I can just, let's go ahead and do this right. Or closer to Mike Merriman right than actual right. Alright, so, ooh, look at that. Look at that. Okay, let's go ahead and strip that off from where I'm damaged the sucker. All right, just right there. And wow, look at that metal. It's a T800 metal. To reinforce what's going on, to reiterate, this is the 50 volt capacitor. Positive side leg is soldered onto the 1 mega ohm resistor at the end of this whole entire daisy chain of the second loop. So if you can see that, that's what you're going to want to end up with. So let's go ahead and wrap it around this bad boy like this, okay? This bad boy. And booyah, like that. And that looks hideous, but it's going to work. I promise you, it works like a charm. Alrighty, just to bring home the point on this one here, as you can see, I soldered a 22 gauge wire to the positive or the anode side of the capacitor. Now keep in mind, it doesn't matter what color you use. This is just going to be the actual signal to this actual terminal block, which you are about to see that I actually solder on. I'm just happen to use the red because it's going to the positive. So again, there's no positive and negative charge. It's just going to actually be the signal to this terminal block when the actual game contestants actually touch the copper plate. This is the signal to the Arduino, letting the 5 volt node to drop. Okay, cut another inch and a quarter, inch and a half, whatever. That's actually probably too much. You don't have to cut that off here, but we're gonna go ahead and do the same thing though as we did with the power input. Okay, so what we're going to do like we did before. Take our finger and pinch it down to Chinatown. Pinch it down. And wrap it around this leg, this stem, or whatever you want to call it, and wrap it around this stem. Look at that. We did twice. We did it twice. That's crazy town. Obviously, I'm fast forwarding, but just make sure you have a good solid connection on both of those terminal legs when you're soldering. So we're going to go ahead and bring that up on it to make sure that's a good connection. That is a good... Yes, that is hot. So now... Okay, just to kind of bring home the point, I did solder on the wire to the two terminal legs here. There's really no rhyme or reason, and it's totally optional. Maybe you might have 2 locations in your escape room where you actually want to have 4 touch points here, and this allows you one of the sides to have 2 touch points. It also just gives you the option to plug it into either one and it'll work. We can actually use this to screw in our copper plate wire or whatever, or in this case our Cat5 cable, and that's one. Now we're going to take our final bad boy of a resistor. Okay, look at this guy. He's like, he wants to be used in the best way possible, and we are going to use him. Okay, and just to confirm, you will be using the last remaining resistor, which is the actual 1K resistor, onto the negative side of this capacitor. It's going to be looking like this. Again, this is the 1K resistor. What we're going to do, pick which one we want to use. We're going to use this one, okay? So this one we have to do surgery on. We got to amputate. Oh my gosh, the leg has to come off, said the doctor. Okay, I'm going to pause it here. I actually did cut off the longer leg of the actual resistor. This is the leg that's actually going to the capacitor. That's just a choice that I used just because I wanted to actually use the leg of the actual capacitor component rather than the leg of the actual resistor. And so this one we're going to actually go to the Arduino. That's probably the best of all the joints that I've done. Alright, so yeah, this probably is the best joint that it did. But just to confirm, this is going to the ground on the Arduino. Flip it over, it'll show you the ground. So I just want to confirm black. You'll see a little bit of red. That's only because it was connected to the other side and kind of the red wire kind of snapped off onto the black. But this is round, okay? It works. You got to wiggle it and make sure it's solid in there on the ground. Alright. So yeah, this is actually a good pause point here. So so as you can see, the capacitor here, this is the positive or anode side, and this is connected to the 1 mega ohm, and it's going into here and then coming out to here, breaking off to the Arduino, which is the ground, and this is the 1K resistor, which is going to a black wire. Again, polarity doesn't matter here. You could use any color wires, doesn't matter, pink, brown, whatever. But these are just the signal wires from one side to the next going to terminal blocks, letting Arduino know that this side has been touched with a hand, this side has been touched with a hand, and it's going to send it all the way to the Arduino up into here, letting the Arduino know to drop the 5 volts so that it can discharge the actual power from the mag lock, turning it off. Alright, and that's what mine looks like. It's on both terminal posts here, and that's what yours should look like if you're doing it the way I'm doing it, okay? Alright, so we're almost there. And you guessed it, we've got to actually solder in the D13, alright? That is good to go. Let's go ahead and clean this up by cutting off this tiny little mountain peak right there. Alrighty, so for D13, which is basically digital 13, all the way in the top left of the Arduino, which you can actually refer to the PDF download schematic that I provided for you. And all I did was just rinse and repeat, just like the actual ground pin. You're going to just try to do your best with soldering on the joint the best you can and make it just solid as a rock. Again, I used a red wire. You can use any color wire for this one as well. I just used red because I felt it was a positive signal. It's just sending a signal to the actual relay module here. Do your best in terms of soldering it onto Arduino. Also too, just to kind of bring home the point, some relays might be a little bit different. They might actually have pins. On this particular relay, it has a DC plus, DC minus, and IN is for the Arduino wire signal. If you can see that on screen here. I'm wiggling that, and that looks good. Let's go ahead and cut this end here. Now we're really going to only cut about 1/4 of an inch on this side. Aren't you guys proud of me? Just 1/4 of an inch. And we're going to just tin this tip a little bit. Yeah, that's so we can put all those wires together and make it a little bit more solid when it's actually going to the terminal of the relay module. So let's just do that. Let's actually put it inside the terminal. And this is where I'm locking in output D13 from the Arduino into the in signal onto the relay that I showed you moments ago. What I'm doing here, and before I explain, I tin the tip here, and what that means is you just put a little bit of solder on the tip of that, combining all the little tiny threads together so it makes one solid final wire. So it goes in a lot easier to the terminal block. So what I'm doing with my tiny flathead screwdriver is I'm actually putting the head into the terminal and wiggling it around a little bit, kind of up and down, very, very softly and gently, just so that we can loosen up the inner metal here, because sometimes when you unscrew this doesn't actually come undone inside the internal workings of the screw, so you have to like loosen it up. You might want to do that to all of your terminal blocks. It being manufactured out of the factory, sometimes the metal tangs inside here gets a little stuck from the actual screw into the terminal. There we go. That's what we want. We want it to go all the way inside, go deep. It's a family show. And let's go ahead and get a good tight connection on that in signal. Look at that. That's not pulling out at all. Now that we've got that taken care of, let's go ahead. This is where it should be. Okay, now that we know the length of that, we are going to actually cut off some more 22 gauge, and we're going to cut that off and cut that off. Alright, about 1/4 of an inch, maybe 1/2 inch. We're doing the same thing with this side. Alright. And what are we going to do? Yeah, you guessed it. We're going to tin the tips. Taking our trusty painter's tape and spreading those open like that. And putting our trusty gear on. Just to confirm, I did shorten up the length of both the negative and positive of the wires. That's actually coming from the 5 volts, which Dan's covering it up. It's the 5 volt regulators over here. So we're getting actually 5 volts from the regulator. That's going to be going into the relay right here. Again, I did tin the tips on both sides, so we have a good solid connection in both sides of each terminal block. So we have the DC in and out, positive and negative charge, and again the positive and negative 5 volts, okay, coming in this direction, sending 5 volts into the relay. Alright, let's go ahead and put this positive to positive. Alright, so we're getting there. We're getting there. It looks really weird and crazy, but we are getting there, okay? Here's the still shot of the actual relay module, 5 volt regulator over here in the Arduino. Just to bring home the point, as you can see, the positive here is going to the positive in here, okay, and the negative, the ground, is going to the ground of the relay, okay? Now you may be asking, why not just actually put these two wires straight into the relay? Well, we actually have this terminal block because this terminal 5 volts is actually going to share power to the actual USB socket here. So we can actually share the same terminal block of 5 volts on the same source. Thanks for hanging. Let's keep going.